Hello, hello. This should be working. So my name is Quinn McCarthy. I'm in CSC223, and today I'm going to be doing a video about SkipList. So I just kind of learned about these recently, that they're cool, that it'd be a good idea to do a video on them. So basically the main advantages of the SkipList are just that they're cool. They're not really they're not really used that often. They're kind of more esoteric and just cool to learn about. But they do have a fast find, and they have pretty good insert and deletion. So now I'm gonna get into the mechanics of a skip list. So how skip list works is, as you see, this is a diagram of a skip list. So usually you'd have a tree drawn out. Instead, this is a skip list drawn out. So basically it's layered linked lists, sort of. So this 14 has a pointer to this 31, but only this 14. And this 14 has a pointer to this 41. And this 14 has a pointer to this 27, right? So that's kind of the setup of, or that's what the diagram means, I guess. So each of these you can think of as levels, each of these little bars. So this is level, call this level, what is it? Call this level 0. And then 1, 2, here I'll do little Roman numerals, 3, 4, and then 5, right? So, let's say you wanted to find an object, right? Let's say we're trying to find uh, 56, right? So then what you would do is you'd start at the top level, your highest pointer level that you have, basically. So you can think of these kind of freeways, is how they describe them. Is that it's faster to go on the fastest freeway. But if you can't find anything, then you go down a level until you can basically find it. So you start right here at this little top node. Then you say, okay, is positive infinity greater than 56 our value, right? So it is greater than 56, so then therefore we just go down. So we just follow this pointer down. And you say, okay, is negative infinity, so then we look at the negative infinity's next pointer. It says, okay, is 14 greater than 56? It's not. So that means that now we move to the node 14. Then we say, okay, what's 14 pointing at? Positive infinity. Positive infinity is greater than 56, so we don't go there. And then it continues like that, so that means that you go down. 31 is less than 56, so we go there. You go down, because 91 is too big. 91 is greater than 56. Then we go over to 44, then you go down, then you go to 56, right? And so you can see it kind of makes a nice little path. And you get a skip, I didn't have to search node 1, I didn't have to search node 27. And you can imagine if I wanted to search node 91, that it'd be me skipping from here to here. So I'd only have to search 1, 2, 3, 4 nodes instead of having to search freaking, what is this, 10. So it can save a lot of time with the find. You might be asking, okay, well, I see all these, freaking levels to it. How do I know when I insert what level to put it at, right? How many, these are each keys, I think they're called. How do I know how many keys to put in my node, dude? Well, you flip a coin. It's actually all random. So for the insertion function, you can see they include a little image right here. You flip a coin, and for each time it flips heads, you add a extra level to that specific node. Whenever it flips tails, you just stop adding them. So you end up with maybe a Bernoulli distribution, but yeah, it ends up with an on average pretty evenly spread out thing, and it makes it so that your insertions are at probably linear time. Yeah, because you'd still have to search through it'd be a big O of linear, but that's not awful, it's not n squared. Let's see, that's kind of So basic concepts. For deleting, you just stitch it like you would normally with any other linked list, because it is basically a layered linked list. Its average complexity time is O of log n for search, insert, and delete. So again, that's pretty good. It does have a splice complexity of O of n though. It's often compared with balanced trees, i.e. AVL, red-black. Its randomization, I think, makes it pretty cool. And then as far as practical uses, an idea I thought of was using it for a leaderboard in like a video game. Because you could do, the number could be the player's like rank, and then it'd make it easy to see, okay, I want to look at the player in like 367th spot. And so you might be able to use a big skip for that find to make it really quick and snappy. For the coding demo, this is not my own code. I was not writing code for this assignment. It's during finals week. So this is all AI generated. None of this is mine. Credit to ChatGPT. But as you can see, we have our little player struct. So I just implemented the basically example that I talked about. I mean, this isn't even VS Code. This is Cursor AI. So this is the SkipList. So you can see the level and how it decides is with sRandom time. This is the insert function. And then this is the search. So you can see it kind of goes, if it's equal to, it starts at the level, sorry, excuse me. And then it goes, kind of rank by rank. This logic is here. I actually have it right here, and this looks way better. Okay. So node's the start, then while the node has one below it, so that means that while it's not at like the bottom line here, then the node goes into node.getBelow. So it's saying, okay, check here. And then while node.next, or sorry, here, like check here. Let me clear these markings to make it more obvious. It's saying, so it's like saying, check that there's a node here, and then saying, get next, so check right here, and then get the key, so the value. So it'd say, is positive infinity greater than, or less than 50? It's not, so we'd skip this. But if it was like 31, then it would be the node equals get next. So that means you'd skip to this one, right? So pretty self-explanatory. It's pretty simple. And then here's an example of it running. So as you can see, we insert Subu, Andy, Yan, Yan, Quinn in reverse order, and it sorts it. Goes winner, me, in the 0th place, then Subu, then Andy. Nothing against Yan Yan. He was my mentor, but you know, I don't really know him that well. So let me just check that that's everything. But I believe that'll bring an end to my. Yeah, don't have to do it from scratch. Yeah, awesome. Have a great rest of your day. Bye.